And now, Mr. Hildahl to go over function quiz number 1.
Oh, thank you very much, Cody. We got the famous and awesome Mr. Hildahl, but we got it. Okay. So, first off, we're going to take a look at a graph. Number 1, lots of questions on this graph. So the first thing we're asked to do over here is to put a box around the maximum of the graph. And the maximum of the graph, which means the highest point, looks to be about right there. We also needed to circle the x-intercepts. It's going to cross the x-axis there and there. So that was where, if you missed one of those, it was half a point off. Then we're asked for the domain of the function. How far does this stretch, okay, from here all the way to here? And it looks like this is somewhere between 38 and 40. So our domain goes from 0 to 38 or 40. Okay, I would have accepted either one. They're both included, and it's a continuous function. Everything in between is filled in. So that's when we use the comma. Okay? What is the range? Now, some of you put 0 to 34 because those were the numbers on the graph. But the graph continues past 34. So you need to say that the domain is what is included in the graph, not just what's labeled on the axis, okay, on the x-axis in this case. The range, again, is how high is the data, or what is our difference in y, and from there to there is about 6. So it goes from about 0 to 6, including 0, including 6, because it includes 0 down here, and includes somewhere around 6 up there. If you put 6.2, whatever, that's right too, because it's an estimate. Is it a function? Yes. It would pass the vertical line test. So if I were to put a vertical line on the page, does it ever cross, I'm going to thin that down a little bit. Does it ever cross more than one place at a time? And the answer is no. So let's go ahead and just make that a little thinner. Okay, so if I move this across, is it ever touching more than one place at a time? It might look like it's vertical, but it's not. I mean, you can never go, that would be instant travel in time if you went vertical on this graph because it's the speed, okay? And their speed can't shoot up, 100% at a time. So it passes the vertical line test, therefore it's a function. What is, now, this is one thing that we really have been spending a lot of time on, and you hopefully are getting this. That's your input. That's your x, okay? So find, when my input is 16, what my output is. So I go over here to 16. Whoops, undo that. So I go over here to 16. Let me just freeze this in place here. I'm going to go over here to 16, and, okay, so I'm going to go to 16. And at 16, what is my output? Well, it looks like my output is, looking over here, somewhere around 6. So about 6. Okay? I keep asking you the question about units. I've been asking you that, knowing this was coming. What are the units for the answer to this? What is this answer? 6 what? 6 miles per hour. Pretty basic, right? Okay. Find what input gives you an output. So what input gives me an output of 5? Well, where do I have an output of 5? Right here. What are my inputs? Well, about 10 and 26. So about 10 and 26. If you had 11 and 27, I counted those. Okay? So those are the inputs that give me an output of 5. Twice I crossed the 5 miles per hour threshold. Okay? What are the units for that? What are 10 and 26? 10 and 26 what? Minutes. That's all I wanted. Okay? All I wanted. These were pretty basic. Most of you did very well on these. When I put 3 into this function rule up here, what do I get out? This would be 4 times 3 plus 1, which is 12 plus 1, 13. This would be, f of 0 would be 4 times 0 plus 1, which is 1. Now here it's saying what input will give me an output of 27. That's where I just make my outputs equal to each other and solve for x. So I get 4x equals 26, x equals 6.5. So f of 6.5 gives me 27. I do the same down here, and I get 4x plus 1 equals negative 3. subtract 1, 4x equals negative 4x equals negative 1. So that answer would be negative 1. Any questions on any of those? Okay. I have a feeling you're going to retake this after we're done here, and you're going to nail it. All right, continuing on to the next page. First thing, and again, tried to make this really clear. Let's read the directions. Let's read the directions first, shall we? Make a graph of a function called f of x, where f of 0 is 20, f of 2 is 16, f of 4 is 10, and f of 8 is 2. It is not linear. It only includes these points. A lot of you lost points on this math test because of reading directions. The axes are labeled for you below the graph to describe a situation. Also, be sure to use a ruler and use consistent intervals. Some of you lost points for that. Okay? First of all, so the first thing I would do is I'd bring out a ruler, and I'll go ahead and show you that. I'm going to bring out a ruler. And let me undo that. Let me get my ruler here. Okay, and I'm going to bring down my ruler. And I know that on the x, what are my inputs? So I'm going to go ahead and write my domain over here. My inputs are 0, 2, 4, and 8. Are those discrete inputs? Yes, it said it's only those points. I was disappointed at how many people missed these. I thought this was an easy problem, straightforward. Those are my inputs. What are my outputs? 20, 16, 10, 2. 20, 16, 10, and 2. Okay? Doesn't matter what order you put them in. Okay? There we go. They're set. They're specific points only. Is this a function? Yes. For each input, there's exactly one output. Okay? Now, if I know that I need to go from 0 to 8 on my x-axis, okay, I want to use 60% of my graph, so I'm going to say that's 8. Okay? So then halfway is 4. Halfway between that is 6. And halfway between that is 2. Okay? Pretty simple, right? Because then I have 0, 2, 4, 6, 8. Some of you put the independent variable, you mix those up and you lost a point. The graph is worth 2 points. Okay? 2 points possible. So then we're going to go ahead and rotate this. Okay? And here's my ruler for up here. And so I need this to go up to 20. So if I make, let's see, if I make this 20, then halfway is 10, and then half of that is 5, and right there is 15. So all I need is consistent intervals. Okay? So now that I've put my consistent intervals on there, I've used my tools, my ruler, I'm going to go ahead and graph these points. So I have 0, 20, I have 2, 16, I have 4, 10, and I have 8, 20. 8, no, not 8, 20, 8, 2. Sorry about that. Okay? Does it say to connect them? Is it a continuous function? No, nothing about this says connect them. It actually says it only includes these points and don't connect them. It's not linear. Okay? So you lost points if you did that. All right? And finally, graph and label below. Okay, so what I thought of is if you go 70 miles an hour for 4 hours, that's 280 miles. Okay? But when I go, I don't go straight through. And I definitely don't have, some of you had a perfectly straight line. And that means that you're going 70 miles an hour. You never have to slow down for a semi. You never have to stop and go to the bathroom. And so that's not realistic. But you didn't lose points for that. So if you did 5 hours, and you did, if this is 280 miles, this is 140, this is 210, this is 70, okay? I would say your graph would look something like this. If you're leaving from downtown Spokane, it's not 70 miles, it's 60 miles an hour at the beginning. So you might get up going to 60. You might travel at 60 miles an hour for a while, and probably not even that long because it goes 70 pretty quick just past the airport turnoff. So you're going to start going, get up to 70. And so you're going to go 70 miles an hour for quite some time, but you're not getting that far in distance, right? So it's more going to look like this. You're going to get up to speed. So after an hour, I will have gone about 70 miles. So and I'm not going the same speed, so it's not going to be perfect. And then if I stopped at Starbucks in Richville, it's going to go like this. And then after 2 hours, though, I should be right around 140. And then let's say I stop. I'm probably not going to stop until Ellensburg for a little bit longer to get gas. So that's going to be just short of the 200 mark. So I'm going to be going along like this. Okay, and then I might go like this. And I'm going to see myself getting to Seattle probably at about 4.5 hours, and this is realistic since we're going for the Seahawks game. So I'm going to get about there. So, in the past, you're never going to be going at constant speed. In the past, you have curves and things like that. Okay? What is the domain? Well, my domain would be 0 to 5. Does it include 0? Yes. Does it include 5? Yes. 0 to 5. This is my domain. This is my input. What is my range? 0 to 280. Is it continuous? Yes. Time, speed, distance are all continuous. So there were actually 21 points on the test. In the grade book, I put it out of 20. So if you got 21 out of 21, you actually got a bonus point. There you have it.